Okay, this is a problem sent in by Chelsea R. on 12/12/18, last December the 12th. It says an 18-foot ladder leans against a wall. The bottom of the ladder is 3 feet from the wall at time t equals 0 and slides away from the wall at a rate of 2 feet per second. Find the v, that is velocity of the top of the ladder at time t equals 2. Okay, I've got a presentation written out, and I'll go ahead and share that with you. And right here we have it. Okay, and it's kind of blurry, but problem for Chelsea R 12/12/18, an 18-foot ladder, okay, leans against a wall. The bottom of the ladder is 3 feet from the wall at time t equals 0 and slides away from the wall at a rate of 2 feet per second. Let me roll this up. Okay, and it says, find the velocity of the top of the ladder at time t equals 2. Okay, figure 1 here in black. Figure 1 shows the ladder with its bottom 3 feet from the wall at t equals 0, where t is time, and x and y are differentiable functions of t. Now let me roll that up so figure 1 is visible. Okay, so you have figure 1. Here's your 18-foot ladder marked 18 foot. Again, it is kind of blurry. So from here to here, 18 feet. Okay, right here, this shows that the foot of the ladder is 3 feet from the wall at time t equals 0. Here's your y distance, the vertical wall. This shows that the bottom of the ladder is moving out at 2 feet per second, and there's that arrow to show that. Okay, and let me go ahead and get my bearings here. Figure 1 shows the ladder with its bottom 3 feet from the wall at t equals 0. T is time. X and y are differentiable functions of t. It is given that dx over dt is equal to 2 feet per second. The problem asks for the velocity of the top of the ladder when t is 2 seconds. 2 seconds after the bottom of the ladder starts sliding. Let me roll this up. Okay, and that is find dy over dt at t equals 2 seconds. Okay, right here I've written capital A is 90 degrees. That's that angle right there. So that's a right angle by the Pythagorean theorem. This x squared distance plus, that's x squared plus y squared is going to be 18 feet squared, no matter how far the ladder slides down. Okay, and differentiation gives 2x dx over dt, you differentiated x squared, plus 2y dy over dt, you differentiated y squared, is equal to 0 because 18 squared, a constant, differentiates to 0. Then, starting right here, dy over dt is negative x over y dx over dt. Okay, and to get that, we just transposed negative x dx over dt. Okay, and it was right here. It was on the left. Now it's over on the right. And then we have dy over dt. Because we divided this y, we transposed it to right here. And again, you started out with y dy over dt. You transpose negative x dx over dt, negative x dx over dt, and then divided both sides by y. So again, we have then dy over dt is equal to negative x over y dx over dt. At time t is 2, x is 3, plus 2 seconds is plus 2 feet of movement for 1 second, plus another 2 feet of movement for a second. And so you have 3 plus 2 times 2 is equal to 7 feet. It then follows that y at t equals 2 is the square root of 18 squared minus 7 squared under the radical sign, and that crunches to the square root of 275. Finally, at t is equal to 2 seconds, dy over dt, right here down to here, is equal to negative x over y, that's a negative 7 over the square root of 275, and then your dx over dt was given as 2. Or the velocity of the top of the ladder at t equals 2 is, this crunches to negative 14 over the square root of 275. Okay, and that negative sign there means downward movement. And so I say or, 14 over 5 times the square root of 11, that's what we rewrite square root of 275, and then equivalent to 0.84 feet per second downward for the negative sign. Okay, I hope that helped. I'm also going to type this in and I'll send it in to you as a typed answer. And thanks for sending it in. And I'll be sending that in also in the typed format. So let me go ahead, and thanks again.